Let's see what is the next one trying to say, children. It seems again quite interesting. What it says: two poles of height a meters and b meters are p meters apart. So we are being given in the diagram. There are two poles. One is pole PQ having height a meter. That of RS having height b meter. So two poles a meters and b meters are p meters apart. Yes, we can see the distance between them, which is RQ. It's nothing but p. Prove that the height h of the point of intersection. So where is the point of intersection? The point of intersection of PQ and RS, that is from the top of the first star to the foot of the second and vice versa. The point of intersection is N. Prove that the height h of the point of intersection N of the line joining the top of each pole to the foot of the opposite pole is AB upon A plus B. In short, I have written besides it, we need to prove h is equals to AB upon A plus B. H is equals to AB upon A plus B. By looking at the diagram, it seems that many children will give up the sum, or rather say this sum is difficult. Mind you, this sum is very easy, children. You just need to know the technique how we can reach to this particular solution. The moment you get that, you are through with the sum. So how we are going to go with it? If you want, you can always write down in short a very brief description about the diagram, right, in your own way in statement form. So what I'm going to write down, PQ is equals to first pole PQ, which is of height A meters, second pole is RS, which is of height B meters, right? How they are separated by P meters. So distance RQ is nothing but P meters. Now something from our side we have taken x and y in the diagram. So we are saying let RT be x, TQ be y. But prior to that, what is the height? Height NT. Height NT is equals to h meter. We say let RT is equals to x meter and TQ is equals to y meter. Let RT is equals to x meter, TQ is equals to y meter. Now children, what? How can I get P? Can I say P is nothing but x plus y? Therefore, I shall say, what is RQ? RQ is nothing but RT plus TQ. Collinearity is the reason. R dash T dash Q. RT is x, which we have taken it. TQ is y. You can say all these under one roof. Equation number 1 given. This is from given or from equation 1. RQ is nothing but P. So can I say P is equals to x plus y? This is my equation number 2. Any problem? So we have not done any kind of actual sum. We haven't started our sum. What we have done is we have just jotted down all those things which are there in the diagram. Now I just want you to demerge the figure. I have said this couple of times, more than couple is what I have stated. The moment you have a merge entity, you go with a demerged one, the figure is going to give you the answer. So what exactly and which figure you want to demerge it and how exactly you are going to do so. So let me show you over here. Children, I just want you people to demerge this one. Can I say this is what I would like to talk about? Can I say it is S R T and then P Q T? Each of them will have something NT. Here also NT. PQR. I'm really sorry. Here it is PQR and here it is SRQ. Sorry for that. And here there is NT. Here there is NT. Demerge it. Visualize it. Visualize the way in which I want you to. The moment you join them, what we get is nothing but our figure. Right? So, since this being a height, can I say this is 90? Always, the poles are perpendicular. This is also 90. This is also 90. If you want, you can jot down this here also. You want, you can jot down this here also. Right, children? What next? Sir, can we prove in triangle SRQ and triangle NTQ? Or can we prove two triangles similar, SRQ and NTQ, by A test? What makes us say A test? Each is 90, common angle. On the same lines, can I say PQR and NTR will be proved similar by A test? Again, each is 90, common angle. Are we done? That's it. Once you prove two triangles similar, then it's all about CSST. And it is that CSST which is going to give us the answer. Because A, B, X, Y, H, P are nothing but the sides of the triangle. They are nothing but the sides of the triangle. So the moment we prove two triangles similar, we should be done. Only thing is we should know how to go for correlation between them. We start off with the first one. In triangle, we shall prove only one. We can say similarly the other one can also be proved. So it's your call whether you prove this one similar to the inner one or you prove this entire similar to the inner one. Call is yours. Any one we shall make it, we shall prove it, show to the examiner, and the second one we can write down similarly. So directly one can say in triangle, one-to-one correspondence is what we have to keep in mind. SRQ and triangle SRQ NTQ. When I say SRQ, I shall take NTQ as one-to-one correspondence. Can I say angle SRQ congruent to angle NTQ? Reason, each is 90. Each is 90. What next? Angle SQR congruent to NQT, common angle. Can I say, therefore, triangle SRQ similar to triangle NTQ by A test? By A test. Let me jot down all those things which are there in the figure. This is B. NT is H. RQ, entire one is P. How about TQ? TQ is Y. Let me jot down here also. PQ is A. NT is H. Entire RQ is P. How about RT is X? Right, children? Let's start. So what will I say? SR by NT. Do I have the values? Indeed, yes. SR by NT is equals to, if I take RQ, we have taken SR and NT. If I take RQ and TQ, does it make any sense? RQ, yes. TQ, yes. RQ I'm having P, TQ is what I'm having as Y. So RQ by TQ. Sir, you have taken the second one. Do I need to take SQ and NQ? Check it out. Is SQ and NQ hold some relation or is something given to us? No. So why we'll write down then? Why we'll write down? Though they form CSST, they form a part of CSST, we don't want it. So I'll simply write down over here CSST. CSST. Right? Jot down the values. What is SR? SR is B. SR is B. What is NT? NT is H. What is RQ? RQ is P. What is TQ? TQ is Y. TQ is Y. Which implies I just want equation in terms of Y. So I want only Y, which is nothing but, I just want only Y, which is nothing but PH by B. Y is PH by B. We'll take this as equation number 3. We'll take this as equation number 3. Now children, on the same lines, whatever I did for this triangle, I want the same to be adapted for the other triangle. So I'm going to say similarly. Similarly. I'm sorry, but this is what we follow so that we understand how our sum goes. Similarly, we can prove, what can we prove? Which two triangle? Triangle PQR similar to triangle NTR. And if I work out on the same lines, you will also get one relation. So what is that relation? If you want, you can say, so it's PQ by NT is equals to QR by RT, CSST. Jot down. What is PQ? A. What is NT? What is NT? H. What is QR? QR is P. And how much is RT? X. Same thing. I want only X. Shall I say X is equals to HP by A? This is equation number 4. Now children, what am I doing? What am I doing with equation 3 and equation 4? Equation 3 speaks in terms of Y. Equation 4 talks in terms of X. What is X plus Y from our figure? Is it P? What is X plus Y? Is it P? And how can I get P? Adding X plus Y. That tells me, add equation 3 and 4. Adding equation 3 and 4, what will I get? X plus Y is equals to PH by A plus PH by B. X plus Y is nothing but P. Is equals to, can I take PH common? What I'll be left with? 1 by A plus 1 by B. Children, I'll take this P, PH, LCM. Will I be writing A plus B by AB? Cancelling P. What I'm left with? H equals to, cancelling P. 1 is equals to H into A plus B. But I just want H alone. So what I'll be saying, this AB goes here. AB by A plus B is nothing but H. And I think so. That's what we had to prove. H is AB plus A by A plus B. What was needed in this question, children? What was needed in this question? In this question, needed was understanding the relation between the two triangles. Prove them similar. Rest of the things will be taken care by CSST. And finally, at the final steps, you just need to know how to get that P by adding X and Y. Sure?